Good afternoon, everyone. So today what we're doing is we're going to be reviewing a new pan that is not yet out on the market, and we're going to be testing it a specific way to see how good it is at fine gold recovery and gold in general. So right here we have a prototype. This is 3D printed. So what we're going to be doing is filling up a pan like this, a 10-inch standard gold pan. This is one we take out in the bush all the time for sampling when we're way up in the mountains and we don't want to carry a lot of stuff. So we're going to be filling this right flush with the surface, and we're going to be filling up this with the same amount. And we're going to be adding 100 pieces of very, very, very fine gold into this one and 100 pieces into that. And we're going to be taking the tailings out of this and sending it in for a sediment sample to a lab and seeing which one recovers more gold. So this pan right here, it's a little heavier than the pan you'd get. It's double walled, and the reason why this is done is so the pan won't warp while we're doing the test, and the actual pan will be lighter and a lot stronger. So this right here, this barrier, you can pan with it in or you can pan with it out. We're going to try doing it without. We've had a little bit of practice with this already. So let's get to her. Okay, so we got our dirt here. This has absolutely zero gold. We went to a creek, pulled this material out, did a whole bunch of test pans, did not find anything here. So this is guaranteed to have nothing, not even a lick of black sand. So what we're going to do is we're going to add an even amount now, and we're going to add 100 pieces of gold. My prospecting partner has been tasked with counting 100 pieces of gold from this vial and placing them in each pan. Okay, so this was a job in itself. We got 200 pieces of fine gold here, 100 in each, and one is going to go in one pan, the other one is going to go in the new pan, and we are going to see which pan performs better for fine gold recovery. Okay, so what we're going to do is we're actually going to classify this material down a bit. We got some 2 to 3 inch size pieces, so we want to get some of those out there. So we got a 1/2 inch classifier. This dam right here will actually help with your classifying. You don't need to classify with this pan, with or without this. So we're going to take it out and use it like that, and let's get started. So we got our classified material here. These pans that we're storing the stuff in, these were washed out thoroughly, scrubbed. Same with the other pan that we're using. So we'll pour our material in, we'll put the gold on the top and do our pans. Okay. So here's the second pan here. So with this test, we know we're going to lose some in the tailings because no matter what, that fine of gold, you're not going to be able to pan it out to perfection, but we will see which one is the better one. Okay, so we got equal material in there and in here, so we'll use this material in this pan and we'll use that material in our new prototype. Okay, so we got our pieces of gold in here, 100 in here, 100 in here. We're going to pour them in our pan and get started. So we got our gold here. Now let's do the next one. So I'm going to wear gloves for these, and I'm going to switch so we don't cross-contaminate the samples. So we got our gold here. I don't know if you can see that. So we're going to pan it down and see. So afterwards we're going to take everything in this bucket and we're going to send that in for a sample. The next bucket over here will have the next sample in it, and that will be sent in. So I'm just going to take my time here. The reason why we chose this smaller pan is it fits a comparable size to the new pan. The new pan fits a bit more, but this one also fits in our bucket. So a typical pan takes about 3 to 4 minutes. New pan should take about 90 seconds to 2 minutes. The new pan basically eliminates this motion right here, and all you have to do is side to side, slightly tilted. Clean this up a little bit on this fine side riffles. Alright, so we got our gold in there. You can see a lot of fine gold in there. So that's the first pan. Okay, so we got our gold here. Definitely looks like we lost some. There's not 100 pieces in there for sure. So that's with your panning very slow. So let's move to the next pan. Okay, so we got our next pan here with our gold up in the top, right there. So the other plus side is we have almost half the amount of water in here. So you can see the thickness of this pan. You don't need as much water. So we're going to try and make this pan in under a minute and a half, and we'll see which one has the better recovery rate. So this pan has quite deep riffles. So to clean up, basically what you do is pan it out of the corner here. So make everything go back there. So we didn't have any gold here that made it past this. We had a couple tiny little pieces here. There's like 3, I think, and we had a bit more here, maybe 10, 20, and then we have a whole bunch right here. Lots of fine gold here. So let's just wash it back. So you can see right there some of the pieces. Alright, so now let's clean this up a bit. You can see all the pieces of gold right there. So to clean this up, you just use the side here. So what I'm going to do is I'm going to link the website, www.placertools.com, and I'll link it in the description. That is the website for this pan. So I think that's as far down as we'll go. Let's take a look here and see what kind of gold we got. So yeah, you got quite a bit more fine gold in there than you did the last pan. So we're gonna bag our tailings here. Regular pan goes in here. These are clean bags. Then we have the new prototype here. Alrighty, so we have our tailings here from the new prototype. Tailings here from the blue pan. Poured into here. This is cleaned out and triple washed. So once our material's in there, we'll pour it in our bags and we'll clean this out again and pour the second one in and pour it in the other bag. So we got our first bucket cleaned out. Here's the first sample. Alright, so we got our next material here. Alright, so we got our pan washed out, all our materials in here. Make sure you guys check out his website. Okay, so when you send in a sediment sample, usually you classify it down to like 80 mesh or so, but we're going to see if the lab will do that for us, so we don't have to have any more contamination than we need. So we're just going to send these in like this if they'll accept it, and we're going to post the assay result for gold, so stay tuned for that. Alright guys, so we got the assay result back. I requested a paper copy as opposed to an emailed copy. That way I know which sample is better at the same time that you do. So sample number 1 is your conventional pan, the blue gold pan. And the new gold pan, the best damned gold pan, is your second sample. So let's open the results and take a look. So we'll look at the results and then I'll explain a little bit about the sample and how it's done. Okay, so I'll quickly explain how they analyze it. So first off, you need a minimum of 650 grams, and they take 1,000 gram of your final prepared pulp, pass it through 100 micron stainless steel screen, separate the oversized fractions. Any plus 100 micron material remaining on the screen is retained and analyzed in its entirety by a fire assay with gravimetric finish and reported as the AU plus fraction, which you can see on here, AU plus fraction. So the minus 100 micron fraction is homogenized and 2 subsamples are analyzed by fire assay with a AAS finish. So you can see that on here. The average of the 2 AAS results is taken and reported as AU minus fraction. And all 3 values are used in calculating the combined gold content of the plus and minus fractions. In the fire assay procedure, the sample is fused with a mixture of lead oxide, sodium carbonate, borax. They use silica and other reagents as required in order to produce the lead button. So the lead button containing the precious metals is compelled to remove the lead, and the resulting precious metal bead is parted in dilute nitric acid, annealed, and weighed to determine the gold content. So the gold values for both the plus and minus 100 micron fractions are reported together with the weight of each fraction, as well as the calculated total gold content of the sample. So your final sample results are here. This is basically the number you want to focus on. So what we said before, sample number 1 is your conventional gold pan, sample number 2 is your best damned gold pan. So this right here, this is just your plus fraction weight of the material that didn't make it through, and this is the minus that did make it through your mesh. So you can see the results. Parts per million, 1 part per million is equal to 1 gram per ton basically. So what you're looking at here is, with the best damned gold pan, your loss for 1 ton of panning out the material is 0.01 grams per ton, whereas a conventional gold pan is 1.42 grams per ton. That is a huge difference between the 2 pans. So there you go. The lab said it all. Those are the results. better check out this pan because it is very good for capturing fine gold. So what we're going to do now is we're going to just quickly head down to the creek and do another quick pan with the best damn gold pan. So we'll see you guys there. And what I'll do after is I'll post a screenshot of the sample preparation methods, sample assay methods, and this assay at the very end of the video. So you guys can take a look at that if you want. So let's head down to the creek now and do another pan. So we're down at the creek, and what I just wanted to do was show a quick video on how quickly you can pan and the use of this dam. So you can see how it's got slight cracks on the bottom. When you use this, it helps with classifying. Definitely good for the beginner prospector. You can take it out, you can leave it in, whatever you prefer. What we want to do now is just show you how quickly you can pan and how you don't need to classify. So we're just going to grab some random material from here. This is a gold bearing creek, so we might find a little bit of gold here. Alright, so we got some material in the pan. We got a little bit more stockpiled right here. And what we're going to do is we're going to pan it out quickly, show you how fast you can do it, and we're going to keep adding a little bit of material. So don't need much water for this. You can see how all the bigger rocks tend to stay on the top. So your material's going through underneath here, passing over the riffles. This material you could simply scrape off if you wanted, or wait till it's all done. So we're just going to add more. So I think that's good. Take the dam out. Get all your material at the back. So the new design is going to have different little cleanup riffles in the back. This one doesn't have anything, but this is a prototype. So there we go. Look at that. We got some gold and some black sand there. There we go. So this is the best dam gold pan, used with or without the dam. Check out the website, guys. I know you'll love it. You're definitely going to want one of these. Perfect for sampling, perfect for moving material quickly. Hope you guys enjoyed the review. We'll see you guys in the next one. Take care.